I am Payal Patel. I'm a principal software development engineer working for core infrastructure team at Yahoo. And topic for today's presentation is Node Manager, how Yahoo manages thousands of node at scale on Kubernetes ecosystem on-prem. Here is a brief agenda for today's presentation, where we'll go over node maintainer / node manager architecture, followed by node auto remediation. We will go into details of some metrics and visualization related to it, and we'll conclude with the major key takeaways from this. So before I get started, I want to give you a brief introduction into Yahoo's journey into Kubernetes. Yahoo started its journey into Kubernetes almost a decade ago. And with that, today we have 35 plus Kubernetes cluster, which contains about 8,000 plus physical hosts. And we are running 2,400 plus application live in production. Recently, we also embarked our journey into cloud as well. With that, we have 35 plus EKS clusters and 16 plus GKE cluster, which also contains about 1,000 plus nodes. So I just mentioned we have 8,000 plus physical hosts. Now, managing these nodes can be quite error prone and time consuming, and it can be quite daunting as well. And there are some challenges related to it. And as a cluster administrator, I have a need where I want to perform OS upgrade, firmware upgrade, Kubernetes version upgrade, and maybe any security fixes coming on the way. You just want to apply that on your entire clusters. Now, managing this kind of task manually can be time consuming and error prone at the same time as well. In addition to that, we needed some solution which is network aware as well. So how do we solve this? We came up with a node maintainer / node manager. What is node manager? It's a Kubernetes operator. Some of the folks we were just sitting in the previous session, there was a deep dive into the what is operator. So it's a Kubernetes operator, helps us to manage or maintain this maintenance related task automatically. Not only it helps us to perform this automatically, it does in a controlled fashion, meaning that as a cluster administrator, I want to ensure that while I perform this maintenance live in production, we want to maintain the healthy cluster capacity at any given time. And while we were building this, we had top 3 requirements in our mind. First is that as a cluster administrator, the operator should have a capability where I can provide list of nodes on which I want to perform the maintenance task. It should allow me to configure the concurrency, which is nothing but that how many nodes I want to process concurrently to perform my maintenance task. And third is the failure threshold, which is just I explained that I want to always ensure that the healthy cluster capacity is always maintained. So for some reason, if the maintenance task goes bad, I want to stop in case of the bad things happens on the production. How do I solve this? So as I mentioned earlier, node maintainer is a Kubernetes operator. Like any other Kubernetes operator, it has its own custom resource called node maintainer custom resource, which allows the cluster administrator a capability where you can configure the list of nodes, provide your checks and conditions, provide your blueprint for the maintenance that has to be performed. It can be Kubernetes version upgrade or simply Unix upgrade. Node maintainer controller. Like any other operator, it uses that custom resource as an input and help you to perform this task automatically. And third one is the node agent, which runs on each and every Kubernetes worker node and actually helps you to execute that targeted maintenance task. Let's dig deeper into each of these components, how they work internally. First is the node maintainer custom resource. So I'm a cluster administrator. I have a use case where I want to perform the Linux upgrade on my Kubernetes worker node. How do I get started with that? I can simply create the resource kind node maintainer, give a name, Linux upgrade. What is the desired state of my nodes to be in? In this case, Linux upgrade version 8.3.2, for example. I can configure concurrency and failure threshold. So at any point of time, if at least 15 nodes fail, I want to stop or pause the maintenance task. So I don't need to worry about the lot of nodes going down if something goes wrong during maintenance. Pause. It's an optional field, but as the name implies is, let's assume that you are running this maintenance task, you are performing Linux upgrade. It can take really long time to finish in one node sometimes, or even Kubernetes OS upgrade, for example. And I want to pause for some reason. You can simply use this Boolean flag and it will stop processing the further maintenance. This can be potentially used where you want to simply pause because it's off hours, you want to pause for weekend, or maybe you have some major release coming on, you just simply want to pause. Timeout, as the name implies, is sometimes while we run this maintenance task, and if the task lands on some bad node or a faulty node, it doesn't give us the feedback or doesn't complete on time. So that, in that cases, timeout really helps you there. Node selector, obviously as the name implies, select the nodes I want to perform on maintenance task on. This is an optional field. If you don't provide, it selects all the nodes in your current Kubernetes cluster, which can be the case for example, where I have Linux upgrade I want to perform everywhere. I'll dig deeper into the next slide about the node selection as well. Config map reference, as the name implies, is here. It contains the actual blueprint or the targeted action, or it can be a simple script where you can want to upgrade one of the CV fix or security fix, and you can just script that into config map. It can pick it up and execute for you. So in case of node selector, like I mentioned, it's an optional field, but let's assume, what if you want to perform certain task on a specific set of nodes? There are two ways to it. You can leverage the label mechanism here, where you can select the nodes with the label dedicated equal to ingress, where it is matching, but I don't want to select out of those nodes where label is stu equal to true. So I can just have a different conditions where I can select the set of nodes on which I want to perform the maintenance. If you want to perform this on a specific host name, you can simply give the actual host name under the node name section. Now in Yahoo, we had certain clusters with such a larger capacity where we have 1400 plus node in one of the clusters. And we have different flavors of the node pool / node group. Now each of this node group can have a different count of nodes as well. So as a cluster administrator, I need a capability where I can configure different concurrency and failure threshold per node group as well. So here in this example, you can see that I have two node groups, identity and stu ingress respectively. I have configured separate set of concurrency and failure threshold. I can also choose to pause a specific node group as well, like I mentioned the pause flag earlier. And bottom of this each node group section, you can see wait parameter. What is that? It simply helps me to add the order of execution of different node groups. So higher the weight, higher the precedence in order of execution. For some reason, if there are multiple node groups has the exactly same value for the weight, they all will get executed in a parallel fashion. So while I'm performing this maintenance task, how do I know the status of my maintenance going on? So node maintainer custom resource, once submitted, it also provides you the view what is going on with your maintenance task. Towards the end of this Linux upgrade, it can be into 3 buckets. Either it is successfully done, errored, or it is simply just timed out. And if you have configured different set of node groups or flavors of the node group in your custom resource, it will also provide you the view at the each node group level as well. How do I view this status? You can simply use kubectl command prompt, kubectl get node maintainer or get nm, do -o-yaml and -w for watching, and you can watch the live status of your maintenance task happening on your Kubernetes worker node. So we've just discussed about the node maintainer controller, node maintainer custom resource. Let's get into a node maintainer controller. Like I mentioned earlier, it's a Kubernetes operator. It uses that custom resource as an input and help me to perform this task automatically. Before executing or putting or dispatching a task, it ensures that all the checks and conditions are met, start executing and give a signal to node agent to start performing the task for me. Because it has a global view of the entire system, how many nodes are there, how many nodes are per node group level, and based on that, it can take the decision whether to dispatch the next batch of nodes or not. In addition to that, I want to simply take a pause here. At Yahoo, whenever we schedule the workload, and by the way, I'm not talking about the latest AI workload, but basic workload where we are always distributing the pod for a given deployment by a rack. So for some reason, if one of the rack goes down in a data center, you don't end up killing all of your pods for a given deployment. So while performing this maintenance task, we also leverage the same mechanism here as well. We group the nodes by the rack and then process accordingly. So there is a lower impact into our Kubernetes worker nodes, workloads. And obviously, control is responsible for providing a status in terms of initialize, in progress, or eventually success error or the timeout. Third is the node agent, which runs on each and every Kubernetes worker node. It keeps checking if there is a signal from the node maintainer controller or not. As soon as sees the signal in form of a node annotation, it starts executing the task. Eventually, after the completion of the task, it will set the status for either success, error, or the timeout. Depends on the status. So now I know working of all three components. How do I get started if I'm a cluster administrator or even our SRE, how they get started with that? They can simply write a script or a task, or in our case, we are using Ansible in order to maintain our Kubernetes worker node. They can put a checks and condition into their script. In case there are BIOS or BMC upgrade, you may want to restart your Kubernetes worker node as well. There are some restart scenarios, they can test it out as well. And eventually, once they are fully tested on some of the test nodes, they can generate the custom resource definition and deploy using CI/CD and wait and watch. So let's go through the overall flow of all three components and how they internally work together. So I'm a cluster administrator. I can create a custom resource, submit to Kubernetes APIs, or deploy through CI/CD. Node maintainer controller, which keeps watching this custom resource, reads that, gets a list of nodes, tag the node with initialize, and node agent, which keeps running on each and every Kubernetes worker node, sees that in form of node annotation, read the node annotation, execute the task, and eventually update the status with success, error, or timeout, submit to Kubernetes API server. Node maintainer controller, which keeps watching this node status all the time in form of lister and watcher, sees the update from the node object and update the node maintainer custom resource back. And that's how the cluster administrator can see kubectl get nm dash watch. So you must have noticed that while we are performing this entire chain of actions, annotation is very crucial here. But what if there is interference from other system, and that can potentially dilute the whole flow? In order to prevent that, we are encrypting this annotation and submitting in form of JWT token, where you're encrypting using the private key of node maintainer, which can only be used by the node agent and use as public key, decrypt that, and start performing the action. So let's talk about node auto remediation. We are doing this maintenance, that works fine. How about node auto remediation? Whenever you want to perform any node auto remediation, there are 5 aspects to it. First is issue detection and isolation. In order to remediate any node, you first and foremost have to detect the issue. You have to find the faulty node. Once you find the faulty node, you want to isolate. How do we do that? We can leverage Kubernetes, drain, and cordon mechanism. Cordon will help us to prevent scheduling new ports to the faulty node, and drain will help us to evict existing pod or workload running onto the faulty node. And at any point of time, while we're detecting any hardware issue on the node, we also want to tag the node for the hardware repair so that our data center engine can physically fix it. And while we are doing entire this chain of actions automatically, we want to ensure that our operator or remediator / maintainer controller does in a again controlled fashion. We want to ensure that it maintains healthy cluster capacity at cluster level plus node group level as well, because it has the entire view of the system. And obviously, as a cluster administrator, you want to have an ability where you can configure different chain of remedial action as well. How do we solve this? All 3 components listed here covers all the 5 bullet points just I discussed in the previous slide. Node problem detector helps us to detect the issue, as the name implies it. Node remediator / maintainer controller, it's the same controller, helps us to cordon and drain and isolate the node. And if there is a hardware issue, it will help me to send to a data center engineer for fixes. And obviously, it has entire view of the system. It can take the decision accordingly. And node agent, like it was helping us to perform the maintenance task, it can also help me to execute remedial action as well. Let's dig deeper into all 3 components and how they work as well. Node problem detector, it's an open source community tool which helps us to actually detect the issue on our underlying Kubernetes worker node. It runs as a daemon set, and it detects the issue based on the regex pattern matching. So on the right-hand side of the screen, you can see I have an example where I configured the node problem detector, where I can detect the memory read error issue using the pattern memory read error on. And similarly, I can detect CPU clock throttle issue using that pattern matching. Once it detects this pattern, and by the way, it detects this pattern based on your either var log messages or general CTL, whichever the plugin you use on Linux system. And let's assume it has detected the issue. It creates the Kubernetes event object for that particular node. Today, we are using node problem detector at Yahoo to detect 25 plus different node issues. Here is an example of the node event, which is produced by the node problem detector. So as you can see that I'm detected memory read error. Count is 13. What is the meaning of that? It means that it has matched at least 13 times the regex I just shown in the previous screen on the machine cube node 9. It is of kind event, and this is the message which actually get mapped with the regex I shown in the previous screen. And obviously, the reason for this event is memory read error. Now, in addition to that, it has all the other metadata about the first time step and the last time it has detected the issue on that node. Here is another example of node pressure, where it happened on cube node 117 and with the count 1. So now I'm detecting the issue. I got that covered using no problem detector. How do I ensure the remedial actions are happened in a controlled fashion? So as a cluster administrator, you can configure node group unavailable threshold percentage. So for example, at any point of time, I can only afford to get 15% of GPU down at any given time. If it goes beyond that, it will alert us. Similarly, general public IP pool, only 8% of the nodes I can afford to have it down. Token expiry, like I mentioned earlier, the node annotation, if you remember, that's a JWT token, and we give the longer expiry. This is specifically used for our machine learning workload, where it can potentially take longer to drain, and eventually node agent can pick it up, decrypt the annotation, and start executing the action. So that's the reason we are using long expiry for specifically GPU-based workloads. Enable action, as the name implies, is for some reason this is a global flag. If you want to turn off the remediator, you can simply set to false, and it will just stop executing auto remediation in your cluster. Default is definitely true for us. So now I configured puts checks in places. How do I configure different remedial action? So here is example of memory error event, which is again event produced by no problem detector. Setting the event threshold count is 500. So if you recall that count field in the event object earlier I shown, which is the count is matches here. So at any point of time, if it count reaches more than 500 in the event object for a targeted Kubernetes worker node, it will trigger this remedial action. What can be potential remedy for this? Simply drain the node and send to a data center engineer for the fixing the memory card or memory stick onto it. There are other cases where you actually want to execute the remedy. You don't want to just simply drain the node. So there is another example in a kube proxy down. I can trigger this remedy action when the event count threshold reaches more than 2. I have enabled action set to true. Confirm reference contains the actual remedial action which has to be executed on a targeted node. And in this case, I don't want to send to data center for fixes, so I can simply just set to false. So how node agent now pick it up? As mentioned earlier, it wait for the signal from the remediator controller and look at this annotation. Let's just dig deeper into this annotation, where you can simply see that it's set to initialized by node maintainer controller. What is the event or remediation to be executed? Your proxy down in this case. If the drain would have been true in this case, it will also provide the status like what is the drain status, in progress, finished, when was the last time the drain happened, how many attempts for remedy I want to execute in case it fails one time. You just want to have the faster feedback loop in that. So it helps in the retrying in case it fails. And it contains a confirm reference, which contains the remedial action to be performed. Node agent, which reads this annotation and execute that config map remedy configured in a repair kube proxy config. In addition to executing this remedy, it tries up to 5 times. So we don't want like, somebody go crazy and say retry 500 times. No, so we have a limit place in like 5 times you can retry in case it fails. In addition to that, it also runs the same certification script, which we call heartbeat script, which provides the healthiness of your overall Kubernetes worker node. So what happens when I'm performing these remedy actions? Multiple issue happens on the same node at the same time. We simply back off in certain events. So we execute this remedial action in order of they are created by the no problem detector. So there are 3 issues happening on my current Kubernetes worker node. I will first execute the current remedy. Other 2 events can simply stand by and back off. So there are 3 criteria we have in place where we simply back off. A, whether node is currently being drained. Maybe node maintainer is also running some maintenance task, right? You don't want to conflict the node auto remediation and the node maintenance because controller has the entire view of your all the worker nodes. Or maybe simply, currently there is other remedies being executed, I can just simply back off other remedies. And we just simply back off even there is just one remedy. Think of the scenario, I am remediating kube proxy, that is the same event keep producing by the node problem detector behind the scene. You don't want to keep processing the same event at least 2 times or 3 times in that fashion. So it just gives a cool off time between 2 different remedies or the same remedy. So here is the original architecture which helped us to do the maintenance task. How did we incorporate the auto remediation? So here is updated architecture. What are the updates here? Mainly it is that node maintainer control started now watching node event which are produced by the node problem detector, and node problem detector which keeps running on each and every worker node in addition to a node agent. So let's get into the flow how it internally works. Node problem detector which keeps running all these checks or the heartbeat script and looking for any issues. At any point of time, it finds any issue, it creates a node event, submit to Kubernetes API server. Controller which keeps watching this node event, sees that node event, finds the node which has the issue, and tag the node with the initialized status. Before sending to a node agent, it also checks if there are certain remedy which requires drain. It also waits for the drain to be completed. Drain is done centrally by the node maintainer controller. Node agent, which keeps again watching the status or the signal from maintainer controller, reads that annotation, start executing the remedial action, again update the status back using kubectl API, and node maintainer, which keeps watching this live status of all the nodes, sees that and update the feedback about the remedial action. Okay, so we are executing maintainer task, we are executing remedial action. How about the visualization and the matrix? How do I see and get the insight about what is happening with my system? So same architecture, I have added 2 more components at the top right section, Prometheus and Grafana. So node maintainer controller also exposes the endpoint which Prometheus can use to scrape the data about your maintenance task or remedial actions, and the same data can be used eventually over Grafana to have the visualization for that. So here is a Prometheus query you can see on my screen where I am performing 2 different maintenance tasks, out of which one is completed, one is in progress. Here is a Grafana dashboard where you can see that last month we performed our Kubernetes version upgrade on one of the cluster. You can see that around 7 AM we started our Kubernetes version upgrade. It completed around 5 PM in the evening with a success rate of 97%. By the way, the size of this node here was 1,000 nodes where we started our upgrade. Out of that 97%, what happened to remaining 3%? They were either into an error or the timeout bucket. And if you filter this query, you can get the list of node names which return into either error or the timeout. Here is another Grafana dashboard where you can see the status of different node groups as well, whether it's success, error, or the timeout. How about node remediation metrics? Similarly, on this Prometheus query, you can see that memory scrubbing error was the highest occurring error with the count of 58, followed by the node memory read error. If you filter this query further, out of 58, 6 nodes where drain actually failed to perform. And if you filter this further, you can find those node names, what happened to them. And similar data can be used over Grafana to project the visualization. So there are many more metrics and graphs which we have, and which really helps as a cluster administrator. Like one of our SRE recently performed that upgrade. I can just later go on Grafana and see the back in time. One node has started, what is its status is in the pause or not, whether it is in progress or not, something went wrong or not, and you can always look back in time. So what are the major key takeaways out of this? Automation is the key. It really helped us to do the management of this node automatically and helped us to save tons of time. The tasks which used to take multiple weeks before, we could finish in matter of, like I just shown an example, 8 hours, where we finished 900 plus node clusters, turn on the Kubernetes custom resource, let it do the job. You can perform these tasks 24/7. You just turn on the operator, it's just doing a job for you while you're just having a coffee or snack. Before, when we used to perform this task manually, it was really painful. Like, it can only cover the shift from 9 to 5. And even though you have a team across the globe, you require manual handoff between 2 different teams, ensure that nobody overlap on each other and whatnot. And it was definitely time consuming and error prone. Enabling the auto remediation really helped us to save time. And in addition to that, having Grafana and Prometheus gave us the ability to see the patterns. For example, I shown memory error was the highest occurring error when we introduced this node auto remediation couple of years ago. And eventually, after our data center engine helped us to fix the memory stick card onto that, the error rate went down, and it helps us to stabilize our system even further. It also provided an insight into a different maintenance tasks. For example, I can go back in time and see that on average, how much one node take to complete Linux version upgrade or Kubernetes version upgrade. For example, I could see that Linux upgrade used to take 40 to 45 minutes per node, versus version upgrade can take 20 to 25 minutes. So you can use the data and you can plan your future upgrades based on that data. Like, I can plan my one of the cluster, I can finish in this much amount of time with this many nodes at any point of time. So with that, I want to thank you everyone for joining this session, and I want to open the floor for any questions you may have.
Thank you, sir. Hi, I have a question. Do you ever get disk thrashing with a workload? So for example, a workload goes onto a node, causes a disk pressure error, and then it has to go to another node while the disk pressure error is being remediated, and it causes a problem in the other node. Does something like that ever happen? Maybe not necessarily with disk pressure, but with other resources.
I can correlate that disk pressure issue with sometimes a noisy neighbor issue as well. Like one of the workload is really churning your CPU cores, potentially impacting some other workload which are not even that much churning your memory and CPU resources. So yes, we do run into that issue a lot. And Node Auto Remediator sometimes helps us to evict certain pods, where we also have the Grafana and dashboard where you can see that on a given Kubernetes worker node, which one is the pod is the highest, using the resource in terms of memory and CPU, so that we can find this is the guy who is causing the issue on my targeted Kubernetes node. Sometimes they can, they can over allocate it, or they are just, throttling in terms of resources.
Gotcha. Thank you.
Have you guys seen how pod disruption budgets have affected the amount of time it takes for a cluster to upgrade?
Oh, yes. That is definitely one of the bottleneck when sometimes, in case of, for example, OS upgrade, we definitely have to drain the node. We cannot do that live upgrade. And in that cases, sometimes as a drain, it will not evict if there is a PDB criteria is not matching, right? So we run into that issue very often. However, we have also maintained that with our customer that sometimes, yes, sometimes we get stuck in time. But what happens with that is that it will never start the maintenance because it always gets stuck in initialized state and it will wait for the complete drain to perform. So that's whenever, we sometimes get a status through our Grafana or Prometheus query, and we can see, okay, this particular node never made to the in progress status.
So then you guys have some sort of way to kind of keep track of which customers or which of your tenants you guys have to reach out to.
Yes.
Okay.
Yeah. I'm not denying that it happens, but yeah, when it happens, our SRE doesn't fancy that.
Okay, thank you.
Hi. I wanted to ask, how do you remediate a node when kubelet is bad? Like the drain would fail on those nodes.
I couldn't hear you. How do you?
Sorry. Too short for this. Okay. How do you remediate a node when kubelet is bad? Because the drain would hang on these cases,
yes.
Right?
So recently, we also leveraged the node program detector itself in a certain cases, because of course the node agent or the node itself doesn't have the entire view of it. But the certain cases where kubelet itself is down, node is not properly registered because we just take it out of the our registry. We don't even serve the traffic out of it.
So do you skip drain in those cases? Do you skip drain?
Do we skip drain?
Yeah.
If you can't connect because kubelet is down, even if you try to perform the drain, it will not accept because it has to be registered with the API server, right? So in those kind of cases, we have alerts in place where we actually, manually fix it because maybe system is hung up. Sometimes even remedial action failed because my remedy action started, but it got hung up because node has some underlying hardware issue.
Got it. And do you know what signals you get from NPD when kubelet is down?
Signals as in
Like
if
what?
so
What
NPD
tells?
generally produces the node event, which I shown you kind event object all the time.
Okay.
So all the different issues keep happening on the node, it keep producing that event, and that's the signal from no problem detector. We leverage it. We keep reading that in a live watcher stream
Okay.
and leverage that.
Okay. Thank you.
I just had a quick question. If you had multiple node maintainer resources that match the same node selector, what happens in that case?
Let me rephrase your question. So if I have multiple node maintainer task which matches the same,
Yeah.
so we also have we generally allow that. I know it can be also conflict with each other. If the task is such like that, it can potentially conflict. But this is mainly handled by our either cluster administrator or our SREs, which know what they are doing. There are times when we have done, for example, two different tasks. One, it can be just simply upgrading one of the binary because we had a security issue. Another is we also leverage this for upgrading some binary running on that Kubernetes worker node. We just want to simply upgrade that version. So we leverage both the tasks at the same time. But as a cluster administrator or as a SRE, we ensure that we should not have the conflicting tasks because if they are overlapping with each other.
Okay. Thank you.
I couldn't find this online, but is No Maintainer Manager open source?
We are planning to open source, not yet.
Thanks.
For my question, for the node controller for the node that needs to be upgraded, that's hosting node controller, how do you guys go about handling the update for that node?
So you're asking specifically in context of upgrading the node?
The node where node controller is running on?
Oh, okay. So where actually the control is running on. So yeah, it can sometimes also happen when node maintainer itself is executing the task. Since it's an operator, it has its own custom resource definition as well. So like any other operator, if you are running on the specific node where maintenance has to be performed, it will be evicted. It can pick up because it has entire view from the node maintainer custom resource itself. So you can repopulate everything into a memory and start processing from there.
Okay, gotcha. And then for the node agent, for some of the operations or the scripts that needs to be executed, do you guys doing any checkpointing, or is it just like how job status, whether it's success, failure, or I forgot other.
Yeah, I did not cover some of the cases due to the lack of time. But for example, when I'm performing the OS upgrade, sometimes even we recently did a BIOS BMC upgrade where you have to reboot your system twice. Now, node agent doesn't know that what is the previous context of my annotation as well, right?
Yeah.
So our cluster administrator, our SRE really script their entire this workflow in a way that it does not end up executing the same task. Like I finished step 1, 2, and 3, I want to start from step 4, not like restart a whole operation again.
Oh, okay.
So that we have that node agent written in a way that it knows that as well. We also add some actual checks in the node agent itself. It knows the previous context of the task as well.
Okay, that's pretty cool. Thank you.
Hi. How do you make it easy to debug? Let's say there's a node maintainer action or a node remedial action, which is a command in a config map, right? So if the command fails, how do you make it easy to debug? Does it bubble up to the status message? Like, does one have to go look at node agent logs?
Yeah, we do not provide the status of all the nodes because the custom resource can go really wild. Like I said, we have 1,500 plus nodes. And if let's say even 100 fails, it's gonna be really look big. So what we do in place that node agent definitely leaves the stresses into var log messages. We also have those data goes into a Splunk where you can also see those logs later on as well, or maybe set the alerts based on that. So you don't actually go into the host. Definitely you can go as an administrator, but we leverage those logging mechanism.
Okay, the std out, std error of these commands are captured in these logs. So that's
Yes.
how you would know what exactly went wrong.
Yeah.
Okay, one more question. If you're aware, is there any equivalent open source project which is equivalent to this?
Yes, there were two actually. By the way, with this product we built in 2018. That time definitely we did not have anything at all. We added the auto remediation like around 2022 or something. So there is another one product, I forgot the name, but there is another. It's called Drano, which helps you to just simply drain the node. However, there were not a single product which were helping us in terms of giving the global view, where I can get as a cluster administrator configure these checks I just mentioned, right? None of those products were helping. They were doing a separate dedicated task. Drano helps us to just simply drain. And then there is another open source project. I think no problem detector. I think if you go to the GitHub page, they are planning to add the remediation. They haven't have that in action because the NPD can help you detect. It can also help you potentially perform the auto remediation. So short answer is no.
Okay, thank you.
Maybe you mentioned before, but maybe I missed. Do you also use it for stateful workloads, like for example for databases? Does it work? How it works?
We use for all kind of workloads. Yes, stateful set can be quite catchy in this particular case. So if you recall that I also mentioned a lot of our, for example, Redis, we have tons of Redis stateful workloads. And I cannot have both master and primary and the secondary down at the same time, right? So the reason for that, that's another reason we are processing certain of these nodes into a group by rack. Because our stateful workloads are distributed across a different rack. So like if one rack goes down, I don't want entire my Redis cluster to go down or the entire primary and secondary relying on the same rack. So having here grouping of rack really helps you. That, I can only afford to get one of the pod in that node. And we also use a pod affinity in addition to that. So no two pods for a same stateful set are on the same Kubernetes worker node. So we don't even have to worry about at least our use case.
Perhaps also the weights that you were mentioning to, for example, upgrade the secondaries before the primary also, something like that.
Right. That's a very specific to Redis operator as well. But in case, anytime you have any stateful workload, in case of Redis primary and secondary, you have to be ready. Even primary goes down, secondary should auto-promote in case of Redis. I don't want to go to details of that, but I think that's enough for each and every stateful set, how you handle. Because you are running into Kubernetes, you have to believe that nothing is permanent.
Yeah.
It can go down at any time.
So do you have implementation specifically for Redis or for the other stateful workloads that you have, or you have a kind of general one that can work with most of your
So this specific solution, like I said, only check we have is the rack awareness, which is an actor awareness. Because we know that our entire stateful workloads are distributed like that. So we can just go, dive in based on that.
Okay, thank you.
Hi, thanks. That was a great talk.
Thank you.
So you talked about the backoff and the remediations.
Yes.
But I didn't see, or maybe I missed, how you prevent like the same remediation from being run twice by multiple triggers. Like once the remediation is run, how do you zero out counters? Is there just like a sliding observation window for the counter triggers?
Yeah, so in that particular backoff slide, I mentioned about the event backoff right here. So I think your question is that there are two remediation or two different node issues found on the same node at the same time. Events are created in order of the timestamp. You saw the timestamp per event object. Okay. So we execute in order of they are created. So if one remedy is happening at the same time, we don't want to execute another remedy yet.
Right. And so you've got like a remediation queue, and
Yes.
do you then just like pass off that if the same remediation was run between the event time and the time?
Correct, yes.
Right.
But we always choose the event which are most recent as of last 5 minutes. So sometimes if the event last, while I was executing current remedy and the previous event which was something else and didn't happen in last 5 minutes, we don't want to process. And if the same event also comes up while I'm processing this, we just simply back off because we don't want to duplicate the same remedy again and again.
Okay.
Hi, the talk was really great.
Thank you.
I had two questions. The first one is this CRD an open source yet, or is it internal to your environment?
We can open source. We don't have any custom code on this. So yes, right now it is not. We are planning to.
That would be really helpful. The second question was, I did not really understand how the CRDs fit into your Kubernetes architecture. I know it runs as an operator, so it might be running on every cluster. Assuming that it might be running on every nodes in the clusters?
So
Or how
CRD
does it
is a
work?
custom resource definition object, which is kind of a global scope object in realm of Kubernetes ecosystem, any operator, which is nothing but the schema which allows you to configure your CR, which is custom resource, which can be many instances. Like you can have a deployment with multiple replicas. So that runs as on an actual Kubernetes cluster. It cannot be per node.
Okay, and how do you manage that? Is it like tough to like manage the CRDs?
We are doing and deploying through our CI/CD. We have a dedicated set of tasks, like major tasks which takes a lot of efforts are OS upgrade, Kubernetes version upgrade, and BIOS VMC upgrade. So we have a dedicated set of tasks already written and CRDs are in place. Obviously, every Linux version is a different capability and we have to update and tune that accordingly. But it can be just simply one pager. You just deploy this using kubectl command prompt. That's all.
Okay, thank you.
Thank you. I think we are running out of time and I can take questions offline. Thank you.